Can everybody hear me? Right, well done, Andrea. Is Andreas? Oh, Andrea. That was really insightful, and at this stage I could really walk away because you've done my presentation, at least half of it, so which means I can really whiz through quite quickly. Now, what's interesting is, I'm Ben Anyasodo anyway, and I work at Jaguar and Rover Research and Technology Department, and I've been there for 7 years and gone through different levels of watching this develop. So yesterday, while I was coming here, I missed my flight from Frankfurt to Graz, and I had 5 hours wait sitting at the airport, and I was really angry. And while I was there, it occurred to me that actually, this is what user experience feels like. Because as a passenger, I didn't care that there was any weather issues, and I expected the airline to get me from point A to point B without any interruptions. Now, regardless of the fact that they had explained to me that, oh, we do apologize, there was a delay in your flight from Birmingham, that's why we couldn't connect you. That still did not make sense to me, because now I've got 5 hours to wait. So if we bring that back into what we're talking about in terms of user experience, it means that we really live in a world of end-to-end user experience, and the demand is getting bigger and bigger. So I kind of want to touch on that a little bit. So by training, I'm a scientist, but my career path is taking me through different shades of this. So from physical sciences, I'm a physicist originally, and then did a degree in computer science and master's in human factors in PhD. So I don't really call myself an engineer, but having to work with them a lot, we get given the names like research engineer. So pardon me if I don't sound very engineering today, because I have no intentions to do that. So, that's the shiny little place where we work. And I thought I'll put that picture up because it's beautiful, isn't it? So here's my notes. I'll read everything here today. Have you got 2 hours? No? Okay, don't worry. It won't be that bad. But I thought to myself, I've got the computer, but what if I printed out my notes? Why do I feel the need to print out my notes? What's going on here? Again, you see why I'm bringing this into the conversation, because there's this constant conflict between the old world and the new world, and between the experience we know and trust, i.e., I can see my notes, and the one that we don't really trust as much because it's a bit unpredictable, and that's the world of computing. So these are the things I'm going to talk about today. The operational environment that we find ourselves in with respect to user interfaces. And I'm going to be working like a newscaster today, an old newscaster. You know how they flip their notes apart from time to time. So I hope that's all right. So yeah, I'll talk about that. And then I'm going to talk about user demands. It's interesting, Andreas pointed on that for a minute when he talked about workload, because that's a very big one. And then I'll talk about Automotive UX. What is it? You know, what state of the art? Where are we going with that? And then the development process. For that one, I will kind of really skim through it because it's already been covered in a sense. And then I'll talk about the industry challenges and the implications on HMI. And then we conclude. So hopefully, I've got enough time to whiz through that without any extra hassles. So what does that environment look like? You probably recognize this if you drive anywhere in the world. There's a lot of hassle on the road. We've got to deal with traffic. We've got to deal with weather conditions, road layout, different sizes and shapes of cars. And all this make the driving environment really complex. And then it's not any easier on the inside because we have something like this going on. And you could call that self-inflicted, isn't it? And that's because we still cannot predict exactly what a user might want to do at what point. So we have to make the interface broad enough, at the same time deep enough to contain access to the level of functionality that a user might need. So it makes it more and more impossible to kind of balance this together. So it's a bit like when we think about driving, you learn what to do with the actual driving task. But using those interfaces inside there, you don't really learn it. And you can say, okay, well, design it well and it will be easy to use. Well, let's think about an aeroplane cockpit and all those controls and things you have in there. So this is how I categorize it. We've got the external environment, and we've got the internal environment, which is the driving-related one. And then we've got the internal environment, which is the non-driving-related one. And if you notice the little food thing going on there, because it's also part of what goes on in the car. And in one user workshop that I organized, users said to me, can I order my McDonald's from the car while driving? And the way it sounded really important to the person, you kind of wonder, oh, well, I was hoping you would say, can I have better access to my bank account or my email or something like that, not McDonald's. But there you go. So there are all these things going on. Now, what's really important? It's continuous when you think about the driving-related task. Everybody does it. You learn how to drive, but you don't want to be in conflict with other road users. You don't want to distract anybody. And we want to give systems that help make that happen and happen seamlessly. It's repetitive and continuous, and you don't practice driving outside of the car. You practice driving only when you're in the car. However, with these non-driving related activities, you don't practice them. It's completely on the opposite. So you can say, with driving related tasks, there's no other mental model apart from what I've learned by driving. So no expectation there. If I make driving easier, customers pick it up. But with the non-driving related activities, they are bringing in mental models and views from consumer devices and how a mobile phone works, how quickly the interface works there, and things like that. And that then makes it rather difficult to meet the demands. And so we go on to user demands. Look how far we've gone. That's quite a lot. So constantly, we have to account for a wide range of users. Look at this graph, if you can see it very clearly. The interesting and surprising thing about this graph for me is that if you look to the far right there, we've got over 2.5 million over 85s in America who are currently driving and who've got driving licenses. And it brings with it the problems such as expectation, knowledge, and abilities of the user, because with the increased life expectancy that we know about, that number is going to increase. And so you're not just designing for people at that end, but more and more people here. The technophobes, as some will call it. So this morning, someone asked me a question around what I think the HMI would look like in the car. Is it going to be simpler? You know, what is it going to be? And I gave an interesting answer, and that's because of that. So a lot of what we have today in the car is got to be retained, just because that's what that user group wants. So that introduces quite a big challenge. And you touched upon workload. So this is a familiar theory that we know, the UX16 theory here, which shows the concept of workload. So not only are we talking about the high workload side of things, we've got to talk about the underload side of things. And where we really want it to be is the optimal performance side of things. Now, how do we make sure that we are designing interfaces that keep the user experience right at that peak? It's not a very easy thing. We've got to do that by experimentation, and experimentation being doing a lot of simulator-type tests. At the same time, simulator is not really the right environment. It's not exact. It mimics the right driving environment, but it's different because when you're actually on the road, things change quite a lot. So how do we balance the requirement for simulator tests with actual on-road tests to make sure that we're getting the workload right? So that's one of the big challenges that we always constantly have to deal with. And we go into the interior of the vehicle. And one of the biggest challenges is to ensure that the position of the occupant in relation to the controls is right, because we've got all these controls. Now, interestingly, people will get in the car and adjust their seats relative to the pedals, not necessarily relative to the controls. And we're constantly being barraged by the need to make the car more spacious. Well, you think that making it more spacious means more accessible. It's actually the converse, because if you make it more spacious, people are a bit, they want to be more relaxed, again, relative to the pedals. The controls are a bit further off. Now, we've got to think about reach and posture. And then we've got to think about the time it takes to sort these things out in terms of, so if you think about the fact that the dashboard is always the dashboard, it's got its geometry, that's not really changing any soon. And then the steering is the steering. It can move up in different directions, yes, but it is still fixed in a certain position. So what then do we do with the controls in terms of making that more accessible and usable to the user? And how do people want to interact is another one. So you touched upon multimodality a bit, and multimodality is sort of what's kept me awake for a few years now in terms of how else do people want to interact with things in the car. Everyone knows about touch, pressing the button. Everyone knows about voice and what's going on there. But then, here's the thing. A lot of the interfaces will actually, they're visual manual, and they encourage a visual manual engagement. Guess what driving as a task is? A visual manual task. So by mental model basis, a user thinks, I want to see the road, but I also want to see what I'm doing, unconsciously. And then you're saying to them, well, you can see the road, but you can talk to your car, or you can feel your car, or you can gesture to your car, and suddenly they're, ooh, that's a bit strange to do in the car. So there are two things there. Engaging multimodally to make it more natural, as it were, at the same time dealing with the user's way of reasoning in terms of what is natural in a car, what is acceptable in a car. So I remember doing some research with respect to gestures, and one of the things that came out was, I don't really think I want gestures, because other road users might think I'm gesturing to them, or I'm being rude to them. You must have experienced this. And it's interesting you talked about the fact that there are many gestures possible, but there's really a limited amount of gestures that people will find natural, intuitive, globally acceptable. And that's the big one. But you've already talked about that. So when we think about touchscreens, iDrive, push buttons, they're all examples of visual manual ways of interacting in the car. But then we want to kind of surface more modalities. How do we do this without changing the way a user is comfortable to relate with it or interact with their car? People spend a lot of time in the cars these days, and it's become an extension of the life space. So if the car is an extension of the life space and you have an expectation of what should or shouldn't happen in the car, how do we begin to affect this behavior or modify this behavior just to make sure that we do what is most important, keep the driver safe? Because a car can be a lethal weapon if used incorrectly. And the way legislation and things happen these days, it first of all becomes the responsibility of the OEM before it becomes the responsibility of the driver. So how do we deal with this? That becomes quite a challenge. I thought I'll show you a little video. I hope it comes up on its own, which is what we're doing in terms of making the interaction simpler. So this is a Predictive Touch, where using some very smart algorithm, the car kind of predicts where your finger is going. And this was a lab test we did. And it selects that for you. It's a kind of finger tracking and predictive algorithm that we've used there. What's interesting is the bar charts on the right-hand side, which we've used NASA TLX to kind of measure the usability and effectiveness of that. It's actually showing that with this little smart technology, we can actually reduce workload and make it easier for the customer. I think I've lost the sound on that, sorry. So let's go to Automotive UX. And we've come a long way. Please don't laugh. You can laugh now. No, it used to be that. It's now that, and that is fast changing. In actual fact, in a sense, this picture is even outdated now. What is the challenge there? There's the size factor, there's the controls, and trust me, we still have many users that want something like this. And so, the user experience people are now getting more and more acquainted with is that of sleek, fast, touch-type interfaces. And yet, although the interior and the controls in the car has evolved quite a lot, it has still maintained a certain model. You still have your on the instrument cluster, you still have speedometers, looking in a certain way. Some people have made attempts to change it to look more digital, and from user studies, people kind of don't get that. They don't understand why you want to change that in a car. People have a certain expectation of what the interior of a car should look like. So we've come a long way, but that's got a lot of implications on where we're going. So BMW introduced the gesture thing, and there's a lot of multimodal research going on there. What are we expecting in future? We expect to see driver monitoring systems becoming the norm, and also behavioral prediction to help seemingly make the car intelligent. For example, automatically setting the climate or audio system based upon the user behavior over a period of time. So I see cars becoming more and more tailored to you, the driver. Does that then mean that as designers or OEMs, we've got a lot to battle? Absolutely, yes. That's not helped us a lot, so I'll talk about this a little bit. And this is the fact that we still, in the automotive space, deal with slow, clunky, confusing systems, and personal device incompatibility all lead to low expectation, which are now being set by the consumer electronics market. So these guys, Apple, like many other consumer electronics people, they've got a 6-month cycle plan with product development. Guess how much we've got with cars? Years. Not 6 months. So most of the time, by the time we get to market, the technology is maybe 3/4 year old. It's already behind. What's happening with customer expectation is still increasing. And then I expect a customer to interact with these controls. He's expecting the controls to be really quick, really fast, and then they're controlling a kind of 2-ton object, which is the car, and they need to be safe. So imagine if we were to say, okay, let's make our cycle plans a bit faster. Let's take a consumer electronics cycle plan. Well, we get into a situation where we can't test these things properly. Because remember I said earlier that the car is a lethal weapon. So not only have we got to test the components, like over-test them, because we need to guarantee them, because if it falters because of a manufacturing error, then we're in trouble. And you cannot put a price to the value of a life. So how then do we balance the customer expectation of that they're getting and building due to consumer electronics with what we know about building cars? So, well, I've got this report I thought I'd show, and it's an accident report. Now, going back to the early days, people just had a few controls to interact with. Today, they've got loads. This report shows that a lot of the accidents aren't because the cars have been built incorrectly. It's just because the customer, the driver, is interacting with a lot of other things while driving. So, whereas we want to surface things for them to use, we're going to remember that what we're doing is increasing their cognitive load. How do you measure cognitive load? How do you determine what to surface at what point? So there are 3 challenges, big current challenges that I would like to dig into a little bit more. And it's autonomy. I was actually hoping you'd touch on that a little bit, Andreas, because I've got questions. I'm confused. I don't know where we go with that. We've got autonomy, we've got electrification, and we've got digital transformation. I don't think these are any surprise to anybody in terms of what's going on in the automotive world as the challenges. Now, let's dig into them a little bit more. How much time have I got left?
Still got 15 minutes and then we'll have some time for questions.
Okay. So, autonomy. It's coming fast, possibly too fast. And I tend to think of autonomy as a classic technology push story rather than a customer pull. So customers haven't said they want autonomy, but we are giving them autonomy anyway. And there are obvious reasons for a customer to want autonomy. I'm just not sure what they will get initially that it would be as compelling as what they want it to be. So when I ask people outside of automotive, what do you want autonomy for? They say, to sleep. I think it will be some time before they will be able to do that. We're talking about that this morning. It has the potential to change everything, and its biggest challenge is what's facing us today. I can't claim to be an expert in autonomy human factors at all, no. I'm not sure anyone can at this stage, but what I can give you is some of the implications of autonomy on interfaces that might influence how we deliver vehicles in the future. One thing is for sure, in my mind, the autonomous functionality we will see initially and for years to come is not truly autonomous. So for some time, there will be autonomous modes, but people will still need to intervene from time to time to drive, and of course, every car will probably be driven manually before we get to the fully automated stage. So, which is what that continuum is kind of expressing, because that's how I see it. There's going to be monitored autonomy way before we get their monitored autonomy. Unless, of course, you're Google, who are coming from a completely different angle in terms of autonomy. So it's no driver at all. So as long as there's a driver in the car, we've got to battle with the balance between partial autonomy and full autonomy. And the conundrum here is that it is coming. Autonomy is coming. There will be significant number of cars that will be sold without it for some time yet. Remember the 85+ category of people that we have to design for. So, the major implication is keeping the driver somehow in the loop of what's going on. They need to be aware of what's going on without annoying or frustrating them. You can't nudge them every time, because then what's the point of having autonomy? However, you still need to tell them what's going on. So if they may not be emailing, they may not be watching Harry Potter, they may be just asleep. How would you then let them know what's going on without making them jump and scaring them, maybe causing them a heart attack or something like that? I'm not even going to touch upon the Tesla driver experience. I think we all had that story and we know it. And had that poor driver paid just half a second attention to the system alert, probably they wouldn't, that wouldn't have been the appendage to that story. So if we link back to the EX-Dodson law that I showed earlier on about arousal, the low end of the underload condition is something we're having to get into more, especially around the area of autonomy. So the driving monitoring systems are becoming more and more mandatory. They are being discussed at EU level at the minute. It's because it's so important that not only do you monitor what's going on in front, so the road, the environmental awareness, but also the driver condition, and then balancing the two of them. What about the driver skill then? What's the impact of that on the performance? How can we control this? As these systems increase, how do we manage the ability of the driver to actually drive? Because if the car is so powerful and intelligent to drive itself, are people going to still keep the skill level? How quickly is that going to drop? Take, for instance, when we had, parking alerts system in the car. So the closer you get into the obstacle, the more it beeps at you. The take rate wasn't initially very high when it came into automotive. Suddenly, it went from there to there. And studies show that there are many people, including myself, who can't drive cars without that. So I remember driving my brother's car once, and I nearly crashed into an object. And then I realized how dependent I've become upon that technology. And that's not autonomy. Having said that, when we're talking about the skills, we're talking about multitasking. So people aren't very great at multitasking. And if the car is going to hand over control to the driver at some point, and they're doing something else, we can't really be guaranteed that they can take it up quickly because people are great at multitasking. How do we deal with that? Knowing that it would change the use of the interior space, which is something else, because if the car is autonomous, people want to use the space in the car to do more things. And the freedom autonomy gives allows for a change in how the space can be used, and it is limitless. We cannot control that. If the dashboard is going to move away and disappear, and the steering disappearing, the seats rotating in all sorts of direction, but at some point the driver needs to take control back, how quickly can this happen? What's the impact of this? How do you show the driver what they need to know when they're using the space in a different way? So these are the things that bug my mind about autonomy. And as I said, I'm not an expert at this at all. If anyone is in the room, please contact me. I would like to know. Let's talk about electrification. So it's driven by the whole CO2 challenge that is set globally, and industries need to meet with that. And there are all these fines that people have to pay if you don't meet it. And we've heard of some of these in the media. Now, the challenge is about how manufacturers would deliver vehicles to the customer with battery hire schemes rather than outright purchase, and also changing how we drive and refuel our cars with charging infrastructures being ever expanding, and that's one of the things going on. In terms of HMI implication of electrification, no system in the vehicle is exempt from the CO2 implications. So, is it working? Yeah. If something requires power, it will invariably be assessed for implications on the power consumption. And the HMI in the car is probably the most power-hungry part of the car at the minute. And we then get this challenge to do displays and interfaces that don't use up that much power. And because part of my work actually is leading the strategy in interaction for future interfaces. And one of the ones that keeps slamming my face all the time is, how do we surface technologies that don't use that much power, knowing that the power has got to come down to the battery at the end of the day? And if we're going to start using dimming screens and things like that, what is the impact in terms of the content that needs to be shown to the customer at what point? What of driver behavior? So people are used to refueling their cars at a certain point or recharging at a certain point. And if we've got to deliver very good interfaces that are not that power hungry, that are very smart, they can dim, and with visual interaction, when you look, it comes back up and gaze and all that kind of smart, beautiful stuff. We also don't want people to need to charge the batteries all the time. But guess what? People have built up a mental model of what battery charging means. Again, it comes down to that, right? But with the kind of batteries we're going to have in the cars for electrification, you can't charge them all the time. So how do we influence the behavior of the drivers with respect to how often they will charge their batteries without making them feel any sense of panic? So probably the battery gauge has gone down and thinking, oh, I need to charge now. But actually, no, you don't, because if you do, you might be killing the battery. So there's that bit as well. What of fast charging, which can have severe effect on battery life if used too frequently? How do you say to someone, yeah, you've got fast charging, but hey, don't use fast charging? How do you manage that behavioral change? Okay, let me quickly just jump onto digital transformation, because the world around us is completely turning digital, and we increasingly try to, with the whole cloud and everything, we want to be connected all the time, and that's such a challenge within the automotive world because the car is connected too. So remote vehicle interaction is with us now, and it's having an influence on how we use and interact with the car. So today, I can, with my phone, check where my car is. I can lock and unlock it. Before I go out in the morning, I simply heat my car up and then go into it. So, but we need to do software updates from time to time, which is something I find interesting in terms of how people react to large change of software or reskinning things. So I find it very, very annoying when one of the apps I'm very used to on my iPad gets updated overnight and it changes the look of it and things like that, because I've learned something already. I'm used to doing it in a certain way already. And everybody knows that managing change isn't very easy, especially behavioral change. So if this is the future, how are we going to get people to embrace this? Right, there are all these vendors, introducing all sorts of services that we can surface through the car. But again, for the customer experience, it's not just about GUI. It's not just about the look and feel. It is about the experience. And if you remember my travel story, they changed my flight. They gave me a meal voucher. They even gave me more than they give others because they realized how frustrated I was. There was a lot of apologies, but I was not satisfied. So in terms of the user experience in the car, we can make the updates happen very fast. We can even make it automated, but we can still have very dissatisfied customers simply because we haven't balanced the user experience properly. What is the user experience? The word is seamless, sleek, almost unnoticed. They want it to be as natural as breathing. And then, well, there we go. We're talking about seamless lives that we live. We all carry this digital signature with us now, with our mobile phone. And even though that by making a little move, just a slight one, I can make payments on things quite quickly. Everything is happening really fast. What happens in the car? I will still want to shop on Amazon while I'm driving, isn't it? Should I? That's a different story altogether. Now, from a manufacturer's point of view, an OEM point of view, when we start talking about user needs, some of the user needs are really not as tangible as we think they are. And they would tell you, if they rank it, they'll tell you, yeah, this is what I want to be able to do in the car. Someone says, wouldn't it be nice that my car just knows everything about me? That would be nice, but it's a car. So we've got that to battle with, and I'm really trying to whiz this very quickly because I would like to have a bit of interaction with questions here. So let me just say that we've come a long way in a relatively short space of time, as it were. There are big, big challenges facing the industry, and some of the things we've already discussed show us already that when it comes to the HMI, and I will use HMI in two ways here, because that's what I do, human-machine interface and human-machine interaction. Those two, the challenges are what we've been going through here, because if we deal with the interface challenges, then we've got to deal with the interaction challenges. That's where technology meets behavior. And we've also mentioned the fact that autonomy has the potential to change vehicle interfaces significantly with the interactions and things going on there. Guess what? That's the last page. So there's quite a huge avalanche of challenges coming in different sizes and shapes and dimensions, swirling rather quickly to automotive UX people and OEMs generally. What do we do about it? So you probably came here for answers while I'm giving you a question. And thank you for your time.